Hello everybody, my name is Rob Osell, and today we're going to be talking about inclusive architecture, or how to build sustainable development teams that include juniors using something that we call the PAMstack. So what is the PAMstack? The PAMstack is just a playful name that we give to three things that we think help build these teams: process, abstractions, and mentorship. We're going to explore each of these three pillars throughout this talk. So why is it that we actually want to be inclusive of juniors? What does that do to our teams? Well, first of all, it means that our teams have less project maintenance because we've built our teams to work where people across different skill levels can contribute meaningfully. And this means that it's going to be easier to maintain those applications. There's going to be less stress on our team. People are going to be more satisfied in their roles. They're going to know that they have opportunities for mentorship and advancement. And this just means that everyone is going to feel like they're a part of the team and again, that they're contributing meaningfully. There'll be a lower cost of developers and a lower cost for our projects. This is again because we have people at all different types of skill levels, which means that we have people doing work that's appropriate to their skill level, and that lowers costs across our whole project. And of course, we're going to have a greater diversity of people on our projects. The junior developer pool is one of the most diverse pipelines of talent in the development industry. To build teams that do not include these individuals is just shooting ourselves in the foot when we're trying to build these types of inclusive teams. Supporting juniors helps bring in inclusive teams. Just take a minute again to reintroduce myself. My name is Rob Osell. I'm a senior engineer at This.Labs. I host a couple of our podcasts like the Modern Web podcast and the This.Labs podcast, and I'm a speaker on topics like this PAMstack, also web frameworks and mentorship. So why aren't juniors successful on our teams? There's a lot of reasons that people give. For example, they say that their software is too critical and they can't afford to have juniors working on it. Or they say that juniors require too much training. Or that they just don't have time to help these people out. Well, the more times that we asked this question and the more answers that we got to this question, the more we realized that while some people believe that the reason juniors don't succeed is because of some fault or something lacking in the juniors, it actually often pointed out to a flaw in the team itself, and that there were things that these teams could do so that all teams, any teams, could support junior developers. So let's look at some examples of why junior developers might fail on these teams. Some teams rely or have poor onboarding documentation. This means that juniors have to ask about absolutely everything. They'd love to answer their own questions and learn and research what it is that they're supposed to be doing. But if that documentation doesn't exist, they only have one option, and that's to ask. This starts annoying your senior developers, and really everybody feels left out. Or teams rely on individual excellence, right? This is where we rely on our senior developers to be bringing to the table a lot of skills that are required to get the job done and deliver products to our customers. When you have this kind of situation, you can't allow juniors to make mistakes. Therefore, you have to have your senior developers constantly micromanaging these individuals to make sure, looking over their shoulder, that they're not making any mistakes. Or you might have an unnecessarily complex code base. This creates a situation where juniors don't know how to contribute because any piece of code that they might want to make a change to looks so intimidating or might cause such powerful regressions that they just are intimidated to make any changes. Or your teams might have no review or mentorship. This creates a situation where juniors aren't getting any feedback or any possibility of growth. They languish in their careers and they stay junior forever. Eventually, your team believes that this is sort of a self-fulfilling prophecy, that this is the reason why not to include juniors, because they never grow. But these things don't just hurt juniors. Each of these hurts your whole team as well. So if you have poor onboarding documentation, that means it's also very difficult to hire new senior engineers and on-ramp them onto your own teams. You're going to have to explain things over and over again to every new person that you hire, and people have to be extremely senior, extremely knowledgeable, or else they sink in your system. There's also the hit by the bus fears that happen on teams that rely on individual excellence. So in these types of circumstances, people are relying on individual excellence and they need to know so much about the system that you worry that if that person doesn't show up to work one day, how is the team going to survive? This doesn't work for any good teams. Then for complex code bases, you have productivity delays. Complex code bases aren't just difficult for juniors to navigate. Mid-level engineers, senior engineers, and even architects struggle to make changes in these kind of code bases as well. These regressions slow down development and make all of your releases much more stressful. And without mentorship, your whole team has a lack of advancement. Again, even your most senior engineers need training and mentorship in order to advance in their careers to become principal engineers or even VPs of technology. Everybody needs this kind of feedback to develop. So let's get back to the concept of the PAMstack. These ideas are supposed to help you build an inclusive team. Now let's focus on the first pillar, and that's process. Now I know a lot of you might hear something like process and want to look to the next video in the list, but just hear me out, give me a chance, because I think this is going to be very valuable to hear. So I'm going to read a description of a team that has very little process. And while I'm doing that, I want you to consider whether this description matches any of the teams that you're currently on, or maybe teams that you've been on previously. If you're watching this in a group, you don't have to out your team right now. On these teams, processes are usually ad hoc and chaotic. The organization usually does not provide a stable environment to support processes. Success in these organizations depends on the competence and the heroics of the people in the organization and not on the use of proven processes. These organizations are characterized by a tendency to overcommit, abandon their processes in a time of crisis, and be unable to repeat their successes. If you, like me, felt like this was attacking you or attacking the team that you've been on, it's okay. We're going to talk about things that you can do to fix this. Because on teams like this, only the rock star developers, this sort of meme that people have been discussing, only those types of developers can thrive. Because only they can navigate the chaos that happens when people abandon their processes and just simply need to get things done. But there are simple ways to make improvements. So let's talk about what would happen if we were doing this right. When process is being done right, we have clear expectations. Everybody knows what's expected of them on the team, and even better, they know what they can expect of others on the team. There's greater team engagement and cooperation. People are working together, and they're also supporting their individual processes and the work that other people are doing. Again, because they understand what other people are doing, they can support them and feel like they're invested in making sure that the team is reaching its goals. There are no single points of failure, because everything that everyone is going to do is being documented and controlled and monitored and recorded. In this way, we don't have to worry that if one person doesn't call into work, someone can simply pick up the process and continue on where that person left off. There's also less stress during the crazy. A big part of this process is making sure that when times are calm, you've thought of all the things that you want to do and all the crazy things that can happen during a development lifecycle. Then when things get crazy, you can take a deep breath, look at the processes that you developed, and then just simply follow your plans with confidence that you've thought through what you need to do and how it's going to work. And you also have reduced conflicts and fewer power struggles. We'll talk more about this later, but the benefits of process is that it means that the things that you do don't seem arbitrary. You're doing things that you intended to do up front, and that means that everybody understands why certain things are happening, especially if there are conflicts between team members. Now, there are many different process methodologies, and no single methodology will claim is best. However, most of these methodologies follow the same general principles. First is to plan. We define expectations. We make sure that when things are calm and times are good, that we write down all the things that we do, all the things that we want to do, and how we want to do them. Then we describe how to meet our expectations, and we train people. We explain how to actually enact our plans and turn those into action. We might build checklists or step-by-step directions or run people through training. Then we want to execute and make sure that our expectations are being met. We want to review things, not just code, but all the things that we do. We want to make sure that we have people in charge of running these processes and making sure that we're following through on our plans. Then you want to measure. Record the results of the work that you're doing. Find meaningful metrics. Again, it's not that there are any magical metrics that will always work for your team, but you want to find things that help you understand what it means for your team to be successful. You want to record those and then see later if those numbers were actually meaningful. And that's the last step, to review. After you've finished a sprint, after things have gotten crazy, when things have calmed down again, review all the things that you did. Have a conversation. Look at the metrics you recorded. Were your plans sufficient? Were there things that they left out? Are there some things that you don't enjoy doing or don't want to do in the way that you've described them? Were your metrics useful? Were there other ones that might be useful? These are all conversations to have to make this process better and better as time goes on. So let's talk about how to create plans. Plans simply are what it is that we want to do. So when times are calm, we sit down as a team and we ask questions like, hey, for this team to be successful, what needs to get done? Who should do those things? How should they actually do them? And when should they do them? All the answers to those questions should then be written down and turned into these plans that you follow. So for example, here's a simple plan, or at least a portion of a plan, for a code review. At the beginning of the plan, we talk about why it is, a purpose for this process. We say why code review is important and why we've deemed it necessary to actually write this down, what purpose it plays in the fulfillment of the success of our project. Then we walk through a step-by-step process on how to complete these code reviews. This is helpful for everybody, again, to lay out what it is that's expected of them. And then we lay out all the exceptional circumstances, again, the things that can go wrong or the things that can go crazy. So for example, what would you do in a code review if the code author and the code reviewer disagreed on a change that needed to be made? Well, in some teams, you might say that the reviewer always wins. The author has to make all the changes that the reviewer asks. Or on other teams, you might say the author wins. It's always the author's prerogative to whether to take the feedback from the reviewer or to deny it. More troublesome are teams where they just rely on the individual power dynamics of the individuals involved, and whoever is louder or more senior or can simply bully the other person can make them do what they want. Instead, our plan here says that the two people involved will try to solve it themselves, and if not, the development manager will solve it. Again, this depersonalizes the conflict and makes things feel less arbitrary. We understand why decisions are being made and how they should be made so that we're comfortable even if disagreements crop up. Lastly, you just continue to build these plans with other circumstances that come up. So for example, we once had people ask, what would happen if there were defects on the code review that we didn't want to address at this time? Is that allowable? As a team, do we want to allow that? And in this plan, we've decided that that is okay. As long as you entered the defects that were unaddressed in the code review in the bug tracking system, that's fine. You don't have to follow this exact process on your teams. Decide what works best for you, but then write it down and follow it with confidence that you've had all your edge cases covered. So another thing to do is to add checklists. Now, checklists are amazing because they can minimize the errors by, again, recording all the things that people need to do to satisfy some of your processes. They help teach new team members, again, by laying out the things that they need to do in a step-by-step process. In the beginning, people might actually print out the checklist and physically check things off as they complete them, but later on, they can just use them as a reference tool. And they reduce cognitive load. So checklists are great for this. No matter how senior you are, no matter how many times you follow these processes, there's going to be a day when you're just not feeling it. You're just a little extra tired, or you're just worn down, or you're stressed out. And it's just great in those circumstances to be able to pull out a checklist and make sure, hey, did I do everything I was supposed to with this? They're very useful tools. Now, we've talked a lot about reviews, and it's because reviews have a lot of positive effects. That's why reviews are critical to good process. Reviews improve quality. This is maybe the most obvious thing. Reviews catch defects or places where people are not following their processes appropriately. Reviews also foster a cross-pollination of ideas. When people are forced to review some work that somebody else is doing, then they have to share information in the course of that review, and both people get smarter. There's also redundant learning. That again, when you review something that you're not typically used to working on, you have to learn a portion of it in order to make that review happen. You're helping to spread knowledge throughout your team. It also reduces stress and eliminates the fear of making mistakes. And this can actually be a little counterintuitive, because when you have somebody that's always going to check all of the work that you do, you might think that you'd be more prone to allowing defects to slip through because somebody's going to catch it on the other side. But in effect, the opposite ends up being true. When you have somebody that's checking your back, you're a lot more relaxed. You're not as worried about letting things get through to the client and getting through to the final product. When you're relaxed, you're doing your best work, and then you make fewer mistakes. So actually having reviews can help create fewer mistakes in a virtuous cycle. But there are many types of reviews. Now, most people are used to using code reviews or something similar to that, but you can review everything. You can review meeting notes to make sure that you all agree on what was said in a certain meeting. You could review designs or requirements to make sure, again, that they actually meet the requirements that you're trying to create. You can review your tests to make sure that there are no gaps or blind spots in the test set. Of course, you can review your code. You can review your plans to make sure everybody agrees that those are the things that you want to do. And you can even review communication to the client, such as emails. This can be invaluable when you want to set a particular tone or make sure that you're not overpromising or saying something that you don't want as a team to the client. Now, at the very end of a process cycle, when we've done a major release and things have calmed down again, we want to pause and introspect. We want to ask ourselves questions like, how did we do? Can we improve our execution or improve our processes? And is there data that we should have captured, or is the data that we captured useful? Just look into the information and the things that you've done and just have open and honest conversations about how you want to do things differently in the future, or emphasize the things that are working really well. For example, on one team that I was on, somebody once looked at the numbers from our estimates and said, you know, we spend consistently between 25 and 30% of the time we spend coding in code reviews. This was very valuable information to us because not only did it help us review future estimates to make sure that we fell within these generally prescribed numbers, but it also helped us create the estimates as well because we had a ballpark figure. This is again powerful because this process and this review process helped us not only do things more correctly, but also do things more quickly. That's the benefit. All right, now let's talk about the next pillar. The next pillar is abstractions. Now in this section, we're going to talk about different technological approaches that can help juniors on your team and realistically help your entire team be more productive. Now, we're going to have this conversation in the context of web development, but a lot of the things that we're going to talk about here can be applied to desktop development or mobile development or realistically any type of development as well. Now, the first thing that I want to say is that web development is hard. All development is hard. On the web, you have to know things like performance, security, accessibility, responsive design, progressive enhancement, browser compatibility, how to build progressive web apps, and realistically, the list goes on and on. Every year it feels like there's more stuff to learn, and it can be very difficult to get to success these days. This leads to a lot of fatigue, and we have to realize that complexity is a barrier to entry in our industry. Every year, developers are trying to learn how to break into our industry, and as they learn new topics, it just feels like there's as many new topics to learn. As they approach our industry, it feels like it recedes in front of them. So we have to do things on our team to make sure that developers can be productive while they continue to build their knowledge level and mature in the technologies that we're using. The good news is that frameworks can help. They make it really easy to do the right thing. They black box a lot of the complexity that has to do with web development and let you get productive building things for your clients right away. And I know that this was very valuable to me personally because when I came from desktop development back to web development, it felt like there were so many things I didn't understand fully. How did cookies work, and sessions, and authentication, and what were HTTP headers, and all these various types of technologies? Well, I was able to use a framework with my team and contribute meaningful code all while I was learning how these underlying technologies worked. It didn't stop me. I didn't have to wait to learn it first. I could contribute right away and learn it as I went along. To give a sense of how this might actually work out, let's look at the AMP framework and what it provides you with its component AMP image. Now this is a really powerful component that realistically behaves just like the image tag in HTML, except that this component will automatically resize the image based on the user's viewport. It can efficiently load and preload images based on how far down the screen the image is located relative to where the user is currently scrolled. The content can be displayed as a placeholder while the image continues to load to prevent the rest of the page from jumbling around when the image pops in. Or you can even show a fallback if the image fails to load again, so that the page represents cleanly to the user what was happening. And if you put this page into things like the AMP cache, it can do all sorts of automatic conversions on those images to make sure that they're using the most performant extensions and that they're also converted to the appropriate sizes relative to the viewports that users are using. Again, all of these things you could do yourself on your teams, but that this component with this framework does for you automatically. Another tool that we recommend a lot is to use command line tools, such as the Angular CLI. CLI tools are an excellent way to avoid the pitfalls that occur when scaffolding a project from scratch. And honestly, ask any senior engineer or architect about the projects that they've been on and some of the custom build systems that they've seen in the past. A lot of times people build these intending to use them on many different projects, but they end up with these bespoke solutions that only work on their individual team and often don't incorporate new technologies as they come online or get updated in any meaningful way. CLI tools are great because they're maintained by the community and always maintain up-to-date standards and all of the latest technology. They can be performant and secure right out of the box with some of the newest things that are available for your library. It also reduces the risk of defects due to using out-of-date or misconfigured technology. Again, we're letting that happen, letting that be controlled by a community of people whose job it is to maintain these tools rather than just that guy that set it up at the beginning of your project. There's also easy migration between major versions of your libraries. So if you're updating your frameworks or some of your other tools, these command line tools are often built with migration tools that help you do that. There's also tons of documentation that's readily available. Again, not only great for your juniors to have that kind of documentation and community that can help them understand issues, but also great for your whole team. And the best part about it all is that technology like this is extremely low risk because you always reserve the opportunity to eject out of the command line interface and manage it by yourself going forward. Now on the web, a lot of people use JavaScript, and JavaScript is an untyped language, but we love to recommend people use type systems for their software. Now, with some teams that use C# or Java, this might be built in, but with JavaScript, we suggest that people use TypeScript. TypeScript has strongly typed methods, variables, and services. It makes it a lot easier to understand what's going on, and it has some really tight integrations with a lot of code editing tools that give you powerful things like IntelliSense that helps reduce the amount of errors that people make and increases the speed at which they can develop new code without having to know all of the libraries and all the methods on those libraries by themselves. And additionally, we're also going to get some really great error detection. Type errors can be extremely common, especially with junior developers, and can cause them to lose a lot of productivity, and type systems really help root those out early on in the process when they're easiest to fix. Now, one common mistake we see with a lot of teams is not being more deliberate about their visual design and component building. So a lot of teams, when they start up, the first month or so is always set aside to build the same types of date pickers or autocomplete boxes or modal windows that they've built on every other project they've ever been on in their entire lives. Or there's another problem that we like to call the Bob Ross effect. And this can happen when people get designs from designers and they simply develop it with CSS and HTML that's completely brand new, as though nothing else existed in the system. Pretty soon, their system is flooded with new and copied CSS rules that continue to weigh them down. Eventually, they start using the important attribute, and then everything's completely lost and unmaintainable from there. This is why we really recommend the use of design systems. So design systems can help improve the quality of a project by eliminating confusion about how to visually implement pages in your application. So this is a shared visual language for your team. It's not just for developers, it's also for the business, it's for the people that write your requirements, and for the designers that work with your teams as well. Now there's a lot of design systems which are well known, like Shopify's Polaris system, and as well as Material Design. These contain a lot of ideas for content guidelines, patterns, CSS classes, or even component libraries that go with that design system. Now similarly, we also suggest the use of component libraries. Again, these component libraries have sets of basic reusable components. Some of these component libraries are things like Material UI, again, Shopify's Polaris system, or things like Syncfusion. Now, these component libraries implement the requirements of our design systems. And more importantly, they help tackle a lot of really important, critical things that can often be difficult to do, such as accessibility, such as responsiveness, or such as performance. And also, the APIs for a lot of these components are often more complete and more thoughtful, again, because it's built by teams who specifically do this as their everyday job. So when you're thinking about re-rolling an autocomplete box without knowing all the accessibility implications of it, it's often a lot easier to reach out to libraries that have already solved those concerns rather than make the same mistakes that countless other teams have made. We also recommend interesting approaches or ways to lay out your architecture using tools like state machines. And I think in the coming years, state machines are going to be in all the software that we build, even in the ones where it isn't now. So state machines define discrete states of your application, meaning some things that are true about your application, as well as some paths on how to transition between those states. State machines have really exploded recently in popularity, with people talking about how to automatically generate tests from these state machines, or how to make really interesting games using state machines, or even developers that have raved about how few lines of code they actually had to change to make substantial changes to behavior because they used an underlying state machine. These things are incredibly powerful at isolating the business logic of your application from its visual design. So here's an example of a large state machine that was shared by someone named Ryan Florence on Twitter. Now, you don't necessarily have to understand or even be able to read all of the details of this image. It's simply to show the scope of how large these state machines can get. This is a state machine that shows the checkout flow for the user's workshop page. Now, it covers all the edge cases, such as what to do if the workshop is sold out, or if the user doesn't have enough funds in order to buy it, or any number of additional edge cases. And because this is all being represented outside of the application, He can verify it, and anyone can verify it without needing to have technical knowledge to read it inside the code base. This means that whether we take this state machine and bring it to an Angular application or a React application, a Vue application, or even a .NET application, we can have some certainty that our application is going to behave appropriately in the way that we expect. We've talked about two pillars so far, process and abstractions. Now let's talk about the final pillar, mentorship. One of the reasons that this pillar is so important to high-functioning teams is because it represents an entire culture shift for your organization. So let's think about things with a bit of a hypothetical. Suppose in your organization it was true that no employee could be promoted unless they could first find somebody to promote into their place. How might that change the way that people interacted at your company? Suddenly, it's not so beneficial to look out only for yourself. You have to be mindful of the other people around you, identifying people that are high performing that could take over your role, and then mentor them and train them to take over for you when you're ready for a promotion. Suddenly, the cult of the rockstar developer fades away, and it's replaced by rockstar mentors instead. Now, mentorship has a ton of benefits for the people that are receiving it. This has been shown time and time again after several different studies. For example, it rapidly accelerates those mentees' growth in their learning. It increases their confidence on projects where they might be unfamiliar. It can decrease their fears of contribution and collaboration and idea sharing, again, because they're getting constant feedback about how to improve and what to do in certain circumstances in which they're unfamiliar. These mentees feel more invested and valued in, and they tend to get promoted really quickly. Some studies have shown that mentees can be promoted up to 5 times more often than people that are not receiving mentorship. And additionally, the final phase is that mentees eventually grow up and become mentors themselves and pass on all the benefits that they received onto other people. Now, a lot of people understand these benefits, and they think that mentorship is like some sort of charity work or a benefit that they give to these people, but that's just not true. Mentorship has a lot of benefits to the corporations and also to the mentors as well that support it. So for the companies, this is a great perk for recruiting. This is a sign of a healthy community and culture at your company that makes people want to work there and be invested in. It increases people's productivity and retention. This means that you're hiring less, you're keeping people on longer, and that those individuals are happier in their jobs. It reduces knowledge silos and removes that hit by a bus thing that we talked about earlier. Again, you're sharing information across your team, which means that in each individual case where someone might leave your team, the impacts of that are far less severe. Now, we talked about how mentorship helped mentees get promoted more often, but it's actually true of the mentors as well. Mentors are also 5 times more likely to be promoted than those who are not doing mentorship. And some of the reasons for this is because in the process of having to work with mentees, to have to learn topics well enough to explain them and to be able to answer questions, to work on your communication skills, these are all things that are important in leadership positions, and this is why mentors grow their own careers as well. You might be saying, okay, we get it. Mentorship sounds great, but how do I actually do that on my team? Well, basically, we just want to create a circumstance where people that are passionate about their work and hungry can continue to share that passion with other passionate people. So for example, obviously we're talking about building formal one-on-one sessions. That's the type of mentorship that everybody's familiar with, and I think is the rock that centers a lot of these endeavors. But we also want to do things like code reviews. We talked about that earlier, about how in the process of doing code reviews, the code author and the code reviewer share various ideas and help each other become smarter about the technology in question. And of course, paired programming can also be a really effective way to introduce mentorship in your teams. It doesn't have to be the only way that you develop, but having people work together and have to solve a problem in tandem and explain to each other the ways in which they want to solve that problem can be a great way to level up junior developers and realistically to share knowledge across your team. And you can create a culture of tech talks. So this is this idea of helping to get people into public speaking, help them learn communication skills by getting a technology that they're interested in, and then just getting a couple people together over a lunchtime or a break or a set time, and then share that information. It can be far less intimidating to get out into public speaking and communicating amongst one's peers than it can be to go to a meetup or to a conference. And these types of things share knowledge about those technologies with the people that attend them as well. Again, we're getting people passionate, we're getting them to share and get other people excited about the things that make them excited. And finally, chat channels. This might be overlooked and taken for granted, but you really want to give people a place where they can talk, again, about the things that interest them, share articles, have conversations, and collaborate with one another. This builds a culture, and again, it shares that knowledge across your team. It's all about building excited teams. So we've talked about a lot of things today, but they can all be summarized into the PAMstack: process, abstractions, and mentorship. Now, for a lot of you, you might be wondering, okay, but I'm a junior developer on my own team. Some of these things sound great, and some of these problems we have, but I'm not senior enough on my team to make people do things. So how can I get some of these benefits as well? Well, the good thing is that there are things that you can do. First of all, you can bootstrap process by simply writing things down. What are people doing? Write the things down that people are doing that you see around you, and then share those things with the team. You can volunteer to mentor and help your peers who are being onboarded, even if you're more junior than them. Show them around, show them the technology. Write down the things that you're showing them or the questions that they had, and again, share that with others. You can ask questions about the project, the code, or the process. Document what people told you, and again, make that available for everybody. Do and ask for code reviews proactively. Walk up to somebody and say, hey, can you show me what it is you've been working on? Or conversely, hey, can I show you what I've been working on? This helps you get the feedback that you need and helps you learn what other people are working on. This can create a culture of mentorship even on teams where it doesn't already exist. And if your team loves that process, if they say, hey, those code reviews you've been doing, those have actually been a lot of fun. I think we should do those as a team. Then get them to agree to formalize that process and continue down this pathway towards building those processes and doing a lot of these different things on your teams. We hope that you enjoyed this look on how to build inclusive teams using the PAMstack, and we hope that you apply a lot of the things that you learned today on your own teams. As you do so, if you want to share your stories of the successes or the struggles that you had, or ask any additional questions, feel free to reach out to us at hi@thisdot.co, or talk to us on Twitter. If you want to find me, you can find me on Twitter at Robocell. That's ROBOCELL. Thank you, everybody, and have a great day.